Good afternoon, one and all present here. My name is Amit Kumar Singh, and welcome back to the class on investment management. Till now in investment management, we have started discussing about the concept of investment. While discussing concept of investment, we have discussed why we should do investment and what are the where we can do investment. Whenever we talk about investment, we can do investment on risk-free assets or we can do investments on risky assets. Why we call them risky assets? Because the returns are not guaranteed. It depends upon the market performance. While risk-free assets are those assets where the returns are guaranteed. Like if you put your money in FD and bank has promised you to give you 6% return, they will give you 6% return. That's why we call them as investment product. While in those products where the returns are not guaranteed, it depends upon their performance. So we consider them as a risky assets. Whenever you talk about risky assets, the very prominent name what comes in our mind whenever we talk about risky assets is the stock market investment. So particularly, what is stock market investment? Any company who have done their IPO, they are listed on the stock exchanges. What we can do in a secondary market, we can buy and sell those shares. So whenever we buy any share with an expectation that its share price will increase in the future. More it will increase in the future, better for us. We'll feel more happy because if we buy something for 200 rupees, if it become 300 rupees, so we are getting profit if we sell whenever we sell it. So the purpose of doing investment, whenever we do investment, particularly in the stock market, is to gain return, a better return, because whenever we talk about the performance of a stock, it depends upon the news what coming about the stock, good or bad news, whatever comes about the stock, that affect its movement positively or negatively. So as an investor, whenever we do investment, we need to every time think about risk and return, risk and return trade-off. We need to always think in the term of risk and return, like how much return I'm getting by taking this much risk. So in order to analyze the risk on a stock, we can look into the beta of the stock. If the beta of a stock is more than one, it is considered to be risky stock. More risk, more return. While if the beta of the stock is less than one, so we consider it to be less risky stock. So whenever we talk about risk on any single stock, whenever we try to measure risk, risk is basically measured by the term called standard deviation. So the parameter which measure risk is the standard deviation. In the first semester, we have studied the subject called statistics. In the subject statistics, when we studied the subject statistics, in statistics, we studied the chapter called measure of central tendency. We studied a measure of dispersion. So in measure of central tendency, we studied about a mean, median, mode. In measure of dispersion, we studied about standard deviation, quartile deviation, mean deviation, range. So to talk about return, I can talk about return in the term of arithmetic mean, geometric mean, mean, median, mode. I talk about risk in the term of range, quartile deviation, mean deviation, standard deviation. But normally, whenever I talk about return, return means normally like in other subjects, whenever I average, I'll use arithmetic mean. Whenever I talk about risk, I'll use standard deviation. Okay, so standard deviation basically talks about the risk on any assets. Okay, so whenever we talk about the risk on any asset, whenever we talk about the risk on any asset, whenever we talk about the risk on any asset, so basically the risk on any asset we measured by the term called standard deviation. We measured by the term called standard deviation. A standard deviation is represented by the symbol called standard deviation is measured by the term called sigma, where the formula for standard deviation is x minus x bar whole square by n, or we use the formula called summation of x square by n minus x bar square. So this is standard deviation. The square of standard deviation, we call that as a variance. I hope you remember this. Okay, so whenever we talk about a single asset, whenever we talk about single asset, the risk on that single asset we measured by standard deviation or we measured in the term of variance. If the same thing is given in the term of probability, if the data is given the term of probability, then we measure standard deviation by the formula called summation of pi into rx minus erx whole square. I hope you remember. So whenever the data is given the term of probability, we measure the standard deviation by this formula, where your expected return is nothing but sum of your probability return into individual return. So that is your expected returns. Already in the previous classes, we have done numerical on this. So whenever we talk about the risk on a single asset, whenever we talk about the risk on single asset, we measured it with standard deviation. But whenever I bring two assets together, whenever you can see in this question number 8, there two assets are there. So the if I bring two assets together, then what happens along with variance, there's a new risk which come in picture, that is called covariance. Covariance basically measures the mutual attraction or repulsion between the two stocks. So whenever there is a single asset, if you're putting your money on single asset, then the risk on that asset is measured by standard deviation. If you're putting your money on single asset, then the risk on this asset is measured by standard deviation. But if you bring more than one asset, then a new kind of risk will come along with variance, that is called covariance. Covariance will come in picture when you have more than one asset. So whenever you have more than one asset, then a new risk come in picture, that is called covariance. So covariance is the mutual attraction or repulsion between the two stocks. So whenever there's a covariance is given, so we measured covariance with a formula called sum of pi into rx minus erx into ry minus ery. Two assets are there, x and y. Okay, so we measure their correlation or regression by using we measure their covariance by using this formula. The other formula of covariance, where the historical data is given, we use the formula called summation of x minus x bar into y minus y bar divided by n. When I give you historical data, we use this formula, or we use the formula called n summation of xy. So summation of x square by n. So 1 minute. So formula. We use this formula called mm, we use called summation of xy by n minus x bar into y. So you use any formula, any, so if probability is given, you use this formula. If historical data is given, you use this formula. Again, I believe you remember that the covariance between the two assets is equal to the coefficient of correlation between them into standard deviation of one asset into the standard deviation of other asset. You remember this formula. So covariance as a factor will come in picture. Covariance as a factor will come in picture whenever you have more than one asset. Till now, in the previous classes, whatever I have gave you an example. Till now in previous classes, in all the example, there was only one asset. So if there's one asset, then the risk is determined only by variance. If you have more than one asset, then along with variance, there's another risk will come in picture, that is called covariance. So remember this parameter. Okay. So the remember this parameter along with variance, a new risk will come in picture, that is called covariance. So now, and I hope you just remember this relationship. Already we have done this in your first semester. So where the covariance, this is the formula. The covariance between the two assets is the coefficient of correlation between them into standard deviation of one asset into standard deviation of other asset. This R of xy is the coefficient of correlation. It is coefficient of correlation between x and y. This is the coefficient of correlation between x and y. Where you remember the coefficient of correlation between x and y is between -1 to +1. Minus means inversely correlated, negatively correlated. Plus means positively correlated. I hope you still remember. So this is what we have studied till now. Okay. So this now what we'll do, we'll solve the problem, question number 8. So everyone, please write down the question number 8. So we'll do the problem. Everyone, please write down the question number 8. It came for 16 marks in last year, January 2019. It came for 16 marks. Everyone, please write down the problem. Okay, everyone, please write down this problem. So let me use Excel for that. So already I've taken the photo of this problem. So I'm just writing down this problem. State of nature. State of nature. Then 1, 2, 3, 4. 1, 2, 3, 4. Then probability. Point 1. Then 0.3. Then 0.5. Then 0.1. Then return on asset 1, return on asset 2. Return on asset 1, then return on asset 2. So this is 5%. So these all are in percentage. So better write. No need to write percentage. So give a symbol here, percentage symbol. So this is 5, 10. This is 5, 10, 15, 20. 5, 10, 15, 20. This is 0, 8, then 18, 26. Okay, so this much is given to you. Okay, so this much information is given to you. Okay, so the first thing, whenever probability is given, the first thing what you will do, the whenever the probability is given, the first thing what you will determine, you will determine the expected return. So you will determine the expected return. You determine the expected return on asset 1. Expected return on asset 1. Similarly, you determine the expected return on asset 2. Determine the expected return on asset 2. Determine the expected return on asset 2. How will you determine the expected return? Very simple. How will you determine the expected return? Very simple. How to determine the expected return? How to determine the expected return? So for expected return, what you'll do, you'll multiply the probability. You'll multiply the probability with your individual return. This would be 0.5. This would be 0.3 into 10. So this would be 0.5 into 15. 15 to 0.5, 7.5. This would be 0.1 into 20. This would be 2. So multiply the individual return, the formula of expected return. So the formula for the expected return on an asset is sum of probability into the individual return. Okay, so now do the sum of this. So what is the sum you will get? Do the sum of this. Do the sum of this. So the sum is your expected return. So the sum is how much? 7.58, 8 plus 5, 13. I believe you will get the sum called 13. So the expected return here is 13%. So 0.5 plus 7, 8, 8 plus 3, 11, 11 plus 2, 30. So this is called expected return. This is the formula for expected return. Any doubt, anyone? Anyone, any doubt? The for asset 2, this is 0.1 into 0. That is 0. 0.1 into 0. For asset 2, this is 0.3 into 8. That is 2.4. This is 0.5 into 18. That is 9. This is 0.1 into 26. That is 2.6. So how much you will get this? This is how much? 5 na? 5 plus 9, 14. Anyone, any doubt? Anyone, any doubt? Anyone, any doubt? Hmm. Bhavna, any doubt? Gitanjali, Harish, Mohan, Pawan, Prakriti, Rakesh, any doubt? Okay. So this is the first thing. You have to find the expected return. Once you find the expected return, okay, good. So once you find the expected return, okay, then what you do? Once you find the expected return, what you do? Once you find the expected return, what you'll do? Once you find the expected return, what I need to do here, I need to find the standard deviation. So standard deviation I need to do now. So the what is the formula for standard deviation? If I have to do standard deviation, what is the standard deviation formula? Standard deviation formula for anything. Suppose x is square root of sum of pi into rx minus erx whole square. So I have to do for each one. I have to find their return minus their expected return. For each stock, I have to find return minus the expected return. For each stock, their return minus expected return. So do for, suppose this is X, suppose this is Y. I hope you don't mind. So this is Rx minus ERX. Then do RY minus ERY. So Rx minus ERX. So what is the first return? 5. 5 minus 13. 5 minus 13. Expected return is 13. 5 minus 13 is minus 8. Okay. These all are in percentage. 5 minus 13 is minus 8. 10 minus 13 is minus 3. And 15 minus 13 is 2. 20 minus 13 is 7. Rx minus ERX. Expected return on X is 13. Similarly, do ry minus ery. 0 minus 14 minus 14. 8 minus 14 minus 6. Then 18 minus 14 4. Then 18 minus 14 18 minus 14 4. 18 minus 14 4. Then 26 minus 14 12. Anyone, any doubt? Any question? Any doubt, anyone? Any question anyone want to ask? Okay, I hope you understood this. Once you did this, now do Rx minus ERX whole square. So minus 8 square 64, minus 3 square 9, 2 square 4, 7 square 49. Then do RY minus ERY. Then 14 square 196, 6 square 36, 4 square 16, 4 square 16, and 12 square 144. Anyone, any doubt? Now for standard deviation, you need this formula. For standard deviation, you need this formula. So till now I found this. Now I'll multiply this with probability. Till now I found this. So now I'll multiply this with my probability. Now I'll multiply this my probability. So if I multiply this with a probability, pi into rx minus erx whole square. Similarly, I'll multiply this with probability. The value whatever you got, multiply that with probability. Probability into ry minus ery whole square. Multiply that with probability. Let me hide this. So I cannot hide it because. So multiply this probabilities 0.1, 0.3, 0.5, 0.1. So probability is 64 into 0.1, that is 6.4. Probability is 0.1 for first. 64 into 0.1, that is 6.4. Then next one is 9. 9 into 0.3. 9 into 0.3. 9 into 0.3 matlab 2.7. Then 4 into 0.5. 4 into 0.5 matlab 2. 4 into 1. 4 into 0.5 means 2. And then 49 into 9 into 0.1. 4.9. Multiply with probability. This rx minus erx, this value what you get, this value what you got, multiply this with probability. 64, the first probability is 0.1. 64 into 0.1. Second probability is 0.3. 9 into 0.3. The third probability is 0.5. 4 into 0.5. And then the next probability is 0.1, 49 into 0.1. Do the sum of this. What sum you will get? Sum 11, 11, 22 carry. 2 carry 6, 8, 10, 14, 16. So this is the variance. Any doubt, anyone? Anyone, any doubt? Anyone, any doubt? Chaitanya, any question you want to ask? Pawan, Mohan, Karthik, Prakriti, Rakesh, any question you want to ask? Gitanjali, Bhavani, any question you want to ask? So this value, no, this value 16. Uh-huh. So this value, no, the 16 what you get, 16 is what? 16 is the variance on first talk. First talk. This is the variance. Variance, this is the variance formula, no? Pi into Rx minus ERX whole square. This is the variance what you get. This is the variance. This is 16. 16 is the variance. So the standard deviation is 4. I hope you understood this. So the standard deviation, if the variance is 16, then the standard deviation would be 4. Similarly, Pi into Ry minus Ery whole square. So multiply this with 0.1. So this would be 19.6. Multiply this with 0.3. You will get 10.8. Multiply this with 0.5. You will get 8. And multiply this with 0.1. You will get 14.4. So the sum of this, how much you will get? 12 plus 6, 18. So this is 18, 1 carry. 12, 12 plus 10, 22. 12 plus 10, 22, 2 carry. 1, 2, 3. 3 plus 2, 5. 52.8. So the variance on stock Y is 52.8. See if any calculation mistake is there. Let me know anywhere. So the variance on stock Y is 52.8. So the variance on stock Y is 52.8. If you want the standard deviation, 52.8. 52.8. The standard deviation is 7.2663. So the variance on stock Y is 52.8. So the variance on stock Y, so the variance on stock Y, variance of the stock Y is 52.8. So the standard deviation of stock Y is 7.2663. Any doubt, anyone? Anyone, any doubt? So I finished the first question. The first set of question was find the standard deviation on a return on of asset 1 and asset 2. So the standard deviation of return 1 is 4. The standard deviation on asset 2 is 7.266. I've done that. Second question is what is the covariance between return 1 and return 2? Asset 1 and asset 2. What is the covariance? So what is the formula of covariance? Before also I've written down the formula. So the covariance between x and y is summation of pi into rx minus erx into ry minus ery. This is the formula of covariance. This is the formula of covariance between x and y. Okay, so Rx minus ERX already I have determined. RY minus ERY already I have determined. Probability also already I know. Probability also already I know. So you see this now. So Rx minus ERX already you have determined. RY minus ERY already you have determined. Probability also already you know. So only thing what you have to do, you have to multiply them together. Only thing what you have to do, you have to multiply them together. Everyone understanding, right? So anyone, any doubt? Everyone is understanding, right? So Rx minus ERX, Rx minus ERX already you have determined. Rx minus ERX already you have determined. Ry minus ERY already you have determined. I'm writing this again just for your understanding so that you people should not get confused. So I'm writing the same thing again. Already we have determined. I'm just writing for you people. Rx minus ERX is minus 8, minus 8, minus 3, minus 8, minus 3, 2, 7, minus 8, minus 3, 2, 7, minus 8, minus 3, 2, 7. This already we determined. Then ry minus 14, minus 6, 4, minus 14, minus 6, 4, 12, minus 14, minus 6, 4, minus 6, minus 14, minus 6, 4, 12, minus 14, minus 6, 4, 12. Probability is 0.1, 0.3. Probability is 0.1, 0.3. Probability is 0.1, 0.3, 0.5, 0.1. This is the probability. Now for covariance, what you need to do? For covariance, what you need to do? For covariance, what you need to do? You need to multiply them together. Probability into Rx minus ERX into Ry minus ERY. You have to multiply them together for the probability. So means minus 8 into minus 14 into 0.1. So 8, 14 8s are 112, no? 14 8s are 112 and 0.1, 11.2. Then minus 3 into minus 6 into 0.3. So 6 threes are 18, 18, 18 threes are 5.4. This is 5.4. 9 6 are 9 6 are 54. Okay, then this is 2 into 4 into 0.5. Answer is 4. And then 7 into 12 into 0.1. So 84, 8.4. So the sum value 8, 10, 10, एक कैरी 1 कैरी ये हो गया 12, 12 plus 5 17 plus 1 18, 1 carry 28. So this is the covariance. This is the covariance between asset X and asset Y. Any doubt, anyone? Any doubt? Anything you want to ask, guys? Because this came for how many marks? 16 marks this question came. टोटल 29 होगी. हाँ, एक मिनट, एक बार फिर से कर लेते हो. 10, 10 एक कैरी. हाँ, ये हो गया 6, 10, 18, 19. हाँ, 29. थैंक यू योगेश्वरी. 29 will be the sum. The sum for this would be 29. Covariance formula. This is covariance formula. Done, everyone. So the covariance between x and y, the covariance between x and y is 29. The standard deviation of x is 4, standard deviation of y is 7.2663. So you know the formula. So the standard deviation of x is 4, standard deviation on y is 7.2663. So what I can do, I can find the coefficient of correlation. The coefficient of correlation, so the covariance between x and y is equal to coefficient of correlation between x and y into standard deviation of x into standard deviation of y. R of xy is equal to covariance of xy divided by standard deviation of x into standard deviation of y. So the covariance is 29 divided by 4 into 2, 4 into 7, 4 into 4 into 7.2663. That will give you the R value. How much the R value will get? The R value you will get is 29 divided by 4 into 7.2663. The answer you are getting as point. The answer you are getting coefficient of correlation value. This is the coefficient of correlation value. Clear? Anyone have any doubt? So done. You 16 marks. Done. You got the 16 marks in exam. Anyone? Any question?